Alright, so what we're looking at this time is that we're going to be going over about 5 different problems dealing with these first 2 sections, and this will be the only video for this this chapter. And we're going over 5 through 8 because they're all dealing with the same basic problem. It's just different parts for the single problem. And then also 29, which deals with how you would set up with doing different samplings. Alright, so let's get started. So the first things first. The city of Cleansburg has about 8,325 registered voters. There's an election for the mayor of Cleansburg. And there are 3 candidates. There's Smith, Jones, and Brown. Yeah, very original names. The day before the election, a telephone poll, so everybody, 680 people are polled randomly and asked who would they vote for, and the following results are what they were. 306 wanted Smith, 272 was Jones, and 102 was for Brown. Now, 5 is asking, give a sampling proportion of the survey. Now, the sampling proportion, if you remember, is just the sample size divided by the total of the population. So in this case, 680 divided by 8,325. And that would work. That would be perfect. Okay. If you want to simplify it, you can. If you want to give it as decimal, that's fine too. But that would be perfectly fine. Now the next one, give the sample statistic estimating the percentage of votes for Smith. All you would do here is that you take however many votes Smith got, which turns out to be 306, and you would divide that by how many people were polled. And that comes up to be about 45%. Okay, or 0.45. So that would be the estimate of the percentage of votes that Smith would get. Smith should get about 45% of the votes based on our survey that we've done. Now, going to number 6. 6, describe the population of the survey. So who's the target population? So who were they going after? Registered voters. The 8,000 registered voters in Cleansburg. That's the population. Now B, describe the sample. The sample was that 680 people that were called and taken part in the poll. That would be the sample. The sample were the people that participated in the data collection. 6C, name the sampling method used in this survey. Now the sampling method in this one, if you look back at that problem, it says that 680 people were randomly called, and so we know we have some sort of random sampling here. Now the question is, did they stratify it? Did they put everybody into a single group? No, they did not. So because of that, it's not going to be a stratified sampling. And basically what happened was everybody got put into a big pot. We stirred it up, and we picked out 680 people. So this would be considered a simple random sampling. All right. Now, number 7 wants to know the sampling error of each person. So they give the actual results. Smith got 42, Jones got 43, and Brown got 15. And it wants to know what's the sampling error of each. Well, to do this, what you're going to have to do is find the percentage for each person based on the poll and then divide it. So like for Smith, we found out that he had about 45%. Right? And then you subtract that by 42, which is what he actually got, which would be a 3% error. Okay. Now, if you were to do the same thing with Jones, you would have seen that Jones got around a 40% on the poll, and he got 43 of the actual. So that means he had a 3%. And if you check Brown, 15% from the poll, 15% actual. So that means we were off by 0%. Okay, and Smith was 3%. And that would be the sampling error. So you just take the actual, or the parameter, vocab word, parameter, and you subtract it by the statistic, or what we got from our poll. Right, number 8. Number 8 is asking about the error. So, is there an error in this? Is the first question. Yes, there is, because as we saw, there's a 3% error for both Smith and Jones. Now, the question is it a chance error, or was it something in our sampling that was a little biased? Now, because we did this randomly, we didn't have people picking people, and we didn't put everybody in groups and have a wrong proportion for the group. Since it was completely random, this would be a chance error. There was nothing we could have done to prevent a chance error. Whenever you do something random, it's always going to be a chance error. All right. If you do a simple random, it's chance. Chance, 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 chance. Unless you're not selecting the registered voters in this case, then it would be a bias because for some reason you're not picking your target population. But otherwise, in this case, this would be considered a chance error because it was completely random for it. All right, 29. Now, what 29 is saying is that you're a fruit wholesaler. So you get all these fruits coming in and you have to try to sell them. So let's say we get our bananas from 3 different companies: supplier A, supplier B, supplier C. Supplier A gave us 75, supplier B also gave us 75, and supplier C gave us 100. Now, what we're doing here is that we have to determine if they're good enough to be shipped. The one thing we could do is check all 250 crates. But we're not going to do that because it's a lot of time, a lot of effort, and it's kind of a waste of time. So what we have to do is we have to try to find a way of doing this easier and quicker and better. So what we're going to do is we're only going to look at 20 crates. Now when we look at 20 crates, we're going to have to say, okay, which type of sampling should we do? So if we were looking at simple random sampling, how would we do a simple random sampling? Well, the way to do a simple random sampling is that we put every single crate gets a number, 1 through 250. We put numbers 1 through 250 in a hat, and we pull out 20 of them. And those are the ones we check. Okay? Doesn't matter where they came from. We're just taking those 20 that we pulled out of our hat. Now, convenience sampling, on the other hand, remember, convenience sampling is what's cheap, easy, and can be done quickly. And what would that be? Oh, there's 20 boxes over there. Let's check those. They're easy to get to. They're right in front of us. Not a lot of effort. Okay, that would be convenience. You just take the 20 closest to you. Now, stratified and quota. Remember, these are fairly close to each other, and there's one small thing different between them. Remember, they both break everything up into groups. So for both of these, you would break it up into the different suppliers. You have a group of supplier A, supplier B, and supplier C. What you'd want is you want a simple proportion for each one. So in this case, you would take 6 from A, 6 from B, and 8 from C. Now, the question is, which ones do you pick? Well, for a stratified sampling, remember, it's random. Okay? It's random. So when you break up into A, you're going to pick 6 randomly. You're going to put them all, you can put them in a hat, and then you can pick 6 out. And you do that for all of them. That would be a stratified. You put them in their strata, their groups, and then you pick them randomly. A quota sampling, you put them in their groups, and you pick the 6 from A, you pick the 6 from B, and you pick the 8 from C. It's your choice. There's no randomness in a quota sampling. All right? Well, that's it.